Firstly, thanks, Carl, for that introduction. I'd just like to say I really appreciate the opportunity to come and talk to you today. So thank you very much to Angus Australia for the opportunity. I really enjoy coming to talk to producers whenever I get a chance. So today I'll be talking about assessing immune competency in beef cattle, and this is a project that is funded by MLA through their mentoring program. And Ian Colett's headed up this project. It started in 2012, and since then, Ian retired, Aaron Ingham's now taken over leadership of that project. And we work very closely with Connie Mallard, who I did a postdoc with over at the University of Guelph in Canada. So hopefully the after lunch session I'll be able to keep you awake for a little while. Christian said he purposely gave me this session just to get us out. Here we go. So a few of you might be wondering what is immune competence, and I guess in a nutshell, immune competence is our ability, is a cow's ability to respond to a disease challenge. So you'll hear me talk a lot today about pathogens, and what I mean by pathogen is any sort of infectious agent that can cause disease. And what this immune competence is not only about you generating an immune response to some sort of pathogen you've been challenged with, but it's about, it's about mounting an appropriate and an effective response. And many of you may have seen what happens when immune responses go awry in the wrong direction, allergy, autoimmune disease, things like that. So I guess the real take-home message that I want everyone to get from my talk today is that immune competence is something we can measure. So we can consider it as a quantitative trait, and we can select for animals for immune competence. So you might ask, why is immune competence important? So we're getting more and more evidence, and especially from very intense production systems, that if we select solely on production traits, that we will inevitably get an increase in the incidence of disease. So a really good example here is the North American dairy industry, where for 20 years they selected largely purely on production traits, with very little emphasis on what we call health and fitness traits, and have landed themselves in a really, really difficult spot where they have a huge amount of health and disease issues in their herds. Animals are breaking down after 2 or 3 lactations. I'm not saying that we have a similar system here, but there's a lot of evidence that as systems intensify, if we don't concentrate on health and fitness traits, that we will eventually get to a point where we start to increase susceptibility to disease. So a good example that I've got up there from the dairy industry is that a lot of important production traits and disease incidence traits are unfavourably correlated. So a good example is milk production and mastitis in the dairy industry. So very unfavourably correlated. As we drive for milk production, what we see is a very significant increase in the incidence of mastitis in those animals. So there's other examples. Here's an example from chickens, where chickens were selected solely for 20 generations on body weight, ignoring anything else. And in the graph on the left, you can see that it's absolutely staggering the difference or the effect we see in body weight change over those 20 generations. But the interesting thing is that when we challenge those animals with some sort of infectious agent, we see that the animals that have been selected very intensively for body weight have a much reduced ability to handle a disease challenge. So selecting for immune competence, it has the potential to increase general disease resistance. I'll talk more today about what I mean by that term of general disease resistance rather than resistance to a specific disease, and why those things are different. And as a consequence, the aim of really selecting animals for enhanced immune competence is to increase the productivity of these animals, improve animal health and welfare, and something that's becoming more and more of an issue for our livestock industry is reducing reliance on antibiotics to treat disease. So of course our main goal with all of this work is to improve profitability for you guys. And a big part of that, I think, in increasing part of that is improving consumer confidence in your product. So we see in the news all the time these days, the public is very aware of the health and welfare of the animals that are producing their food. Sorry, not very often on the bar. That'll be better. Sorry. So there's a lot of, the public's very aware and is becoming continually more aware of the health and welfare of the animals that are producing their food. They're very aware of use of antibiotics in the food that is produced. So it's very important that we very early on start to consider some of these things and maintain consumer confidence in the products that our livestock industries are producing. So there's a couple of different strategies to improve disease resistance, and you would all be familiar with quite a few examples out there. A good example in the sheep industry is where we've been very, very successful in breeding for resistance to parasites, internal parasites. In cattle, we've been able to breed for resistance or susceptibility to brucellosis. But the track we've gone down is quite different, and what we're looking at is working towards selecting animals with what we call enhanced general immune responsiveness. So this is what we're talking about here is animals that are resistant to a variety of diseases and not just specific diseases. And that's a really important point. So we'll talk a little bit more about why that is important. So really the problem that I think livestock industries are faced with is that as we increase emphasis on production traits in our selection, that we know from other intensive industries that the incidence of disease will increase if we don't address it. So the possible genetic solution that we're trying to come up with is where we combine those important production traits with immune competence traits into some sort of weighted selection index. So what we're trying to do is still obviously continue to breed those high producing animals, but animals that also have enhanced general disease resistance. So I won't go into too much about the immune system. We don't. This won't become an immunology lecture at all, but we do need to know a couple of basic characteristics of the system so you can understand about the methodology that we've used to try and measure this trait. So you can really think of the immune system, it's simply just a sense organ, that's all it does. And what it senses is things that are self or non-self, or things that are supposed to be there versus things that are not supposed to be there. And when it senses things that shouldn't be there, so these are pathogens, bacteria, viruses, whatever you like, it then activates a series of host defense responses to try and get rid of those foreign molecules or agents. So all I really want you to take from this slide is that there's two different parts to the immune system. There's an innate part. That's the part that happens very quickly. So if you cut yourself, very quickly that innate immune system will kick in and try and come on board very quickly and control any infectious agents that might gain entry through that cut, etc. So as I've written up there, the innate system is very fast. It's largely non-specific, meaning it doesn't really care what it's fighting. It just gets in there and fights because it needs to do something quickly. And what I mean by this term, germline encoded, means it just simply means that it doesn't get better with subsequent exposures to the same pathogen. It just kicks them on. So you can think of the adaptive response as the kind of response you're after when you go out and vaccinate your animals. So this is a response that's slower to develop. You know, if we vaccinate animals, it takes a while for them to build up protection. It's very highly specific for the thing you are targeting. And it's this thing called somatic hypermutation, which means as you're exposed to the same pathogen over and over again, that acquired response gets better and better each time it sees it. So if we drill down into adaptive immune responses a little bit further, I just want you to see that there's really two different arms to it, and we're just going to call them type 1 and type 2 responses. But the important thing is, when you're faced or a cow is faced with a challenge from an intracellular pathogen such as a virus, it tends to send this arm of the immune system in the fight for you. Whereas if it's an extracellular type pathogen like a worm, for instance, it tends to go down this track to fight that pathogen. So you'll hear me refer to these things as cell-mediated responses and antibody-mediated responses as we go through the talk. But the important point here is that if we're selecting for resistance to a specific disease that largely requires one arm of this system, we can inadvertently be selecting for susceptibility to something that's controlled by this arm of the system. And that's the whole basis behind why we are trying to select for general immune responsiveness rather than responsiveness to a specific disease. So I don't want you to think I'm advocating we should stop selecting for specific resistance to specific diseases, because that's not what I'm saying at all. There's certainly a lot of very economically important diseases which we need to continue selecting specifically for resistance to those diseases. But what I'm advocating is we need to combine that with general immune responsiveness to avoid selecting animals that might be susceptible to a different type of disease. So this is just a little diagram we often put up. It talks about, the important thing to get from this is that the immune response is a whole huge amount of additive genetic effects which lead to your ability to respond to a disease challenge. So it's very difficult to tease that out. But underlying this, although the immune response is underlined by a very complex genotype, there is a measurable phenotype that we can go out in the field and measure. And what we're aiming to do is take measures of both of these arms of the system so that we end up selecting or identifying animals that are pretty good at doing both of those things, and that hopefully will have a better ability to resist a bigger variety of disease challenges. So I just wanted to, some people might not be familiar with, I'll talk a lot about phenotype, and what phenotype really means. It's just what we see is how I describe phenotype, and it is really just a combination of the genetics of that animal plus the environment that it's in. So when we say an immune response phenotype, it's what we're actually measuring out in the field. So how do we go about selecting for general immune responsiveness? So what we do is we induce both type 1 and type 2 immune responses in the animals. We come back and we assess those responses, but the important thing is that we then combine measures of both of those different types of immune responses to come up with our immune competence phenotype. So we're not interested in animals that are really good at this one and really crappy at this one. What we're after are animals that are average or above average for both of those. So we're trying to avoid breeding susceptibility to other diseases. So here's a little bit more about how we actually go about testing, and it's quite a simple procedure, and it needs to be so that it's a practical thing to apply on farm. We don't expect producers to be getting animals in 50 times for us to do our measures, so we constantly trying to fine-tune the testing procedures to make them more practical to carry out on farm. So the work I did in Canada where this methodology really started, and that was in the dairy industry there. So Bonnie Mallard and Bruce Wilkie have been working on this for probably 20 years over there, so I've certainly just jumped in late in the game, so I don't take credit for the idea here. This was very much their idea. But they use specialised antigens that they've developed over many years to actually induce the immune responses. Now, slightly different scenario in the dairy game, because those cows aren't going to slaughter for quite a while, whereas we're testing beef calves that will be going to feed like going to slaughter. So we have to be very careful what we put in those calves. So although it's not ideal, what we use are commercial registered vaccines, so that it doesn't restrict the sale of those animals for you guys, and that's a very important part of it. It's no good us injecting something into an animal and telling you can't sell it for 2 years. So we've gone down the track of using commercial vaccines. There is a challenge to doing that, but that's the track we've gone down. So the type 1 responses we assess using the skin test, and if you're familiar with the old TB test, or how they used to do the old TB test, it's very similar. So what we do in the caudal fold here, so I spend a lot of time looking at cows' bums, is we actually inject a little bit of antigen just intradermally in the skin. We come back 48 hours later, and with calipers we actually measure the size of that reaction lump. So that's the skin test, and that gives us an indication of type 1, their type 1 responsiveness or their cell-mediated responsiveness.
So the type 2 responses we assess by measuring production of antibodies in the serum to the vaccine components that we've vaccinated the animals with. So down the bottom here we have a bit of a timeline of how this works. So we coincide the start of our testing with the day of yard weaning. We'll talk a little bit about why we do that in a little while. So we come on to the farm the day the animals are weaned. We collect a blood sample from those animals to give us a baseline for antibody and for other things we look at. And then we immunise the animals at that time. We come back then 14 days later, and that's when we do these injections for the skin test. And then we come back another 2 days after that. We need to allow 14 days here for the immune system to actually respond to the antigens that it's seen. So it doesn't happen straight away. We need a little time lag there. So we come back at day 14, we do the injections for the skin test. That's to assess the type 1 responses. We come back 48 hours later and we look at the size of those reactions, and we also take a blood sample to look at how much antibody those animals have produced to the vaccine that we've given them. So what have we learned about selecting for immune competence in other production animals? So the heritability of these kind of traits that we've seen in other species. So by heritability I mean that the proportion of the variation we see in a trait that we can attribute to genetics. So in pigs, all of these are low to borderline moderate, I guess, but it's encouraging enough to suggest that we can actually select for immune competence and we can make reasonable genetic gain in the trait. I mean, they're not high heritabilities, but they're not as low as some other traits that we've successfully made progress in. So as I mentioned, a lot of this work was done in pigs very early on, and a substantial amount of work's been done in dairy cattle in the last 10 years, and that was the work I was involved with when I was in Canada. So just to give you an idea of what happens when this is in dairy again, and in a housed dairy cattle system in North America, so I acknowledge it's very different to our pasture-based beef production system here. But in some ways, there's some links to what we would see in a feedlot environment, is that if we go out and test animals and assess their immune competence phenotype and then look at the incidence of disease, we see some very interesting things. So in dairy cattle, we see these are animals which we classify as good immune responders, if you like, average or low. And as you can see, in the high immune responder animals, we have a significantly reduced incidence of mastitis in these animals. So this is in a commercial environment where we followed the animals through for several years after we've tested them. We get reduced metritis or uterine inflammation, increased milk production. So more recently, since coming back to Australia, we've started to do a little bit of work in dairy animals on pasture, and that's only really ticked off over the last couple of years. So Josh O'Leary, who's a PhD student of mine down at the University of Melbourne, is doing some work in this, and he's just starting to gather some data now. But one of the interesting observations is that the high immune responder calves grew a lot faster than the low immune responder calves. So in pigs, as I mentioned, the early work, there's a lot of evidence from the early work in pigs to show that the high immune responder animals have lower disease and higher growth rates. So that gives us some hope that hopefully, the same thing will apply to the beef world.
Converse to what you started with when you said selecting for high growth can result in...
Yes, and we'll talk about that in a little moment. Yes.
Sorry.
No, it's a good point, and we'll talk about that in a moment. Because this, and I've got a particular slide that addresses that exactly. Okay, so in the dairy game in North America, this technology's gone a long way to the point where they have EBVs for immune competence, and CMEX in North America has licensed this technology and are now supplying EBVs for immune competence with their sires for AI. So this is out there in the industry there, well and truly. But what's been really nice to see is that since it's been out in the industry, if we go out and look in herds, dairy herds where there's immunity plus sires that are identified as having enhanced disease resistance, versus animals that haven't been tested, so they're run in the same herd, same environment, the incidence of mastitis is about half in the progeny of those animals. And And there's been a significant reduction in the incidence of pneumonia in those animals as well. So we've taken the work that I did in Canada, I guess, a little step further in that we're really, if we think about the type of environmental challenges that an animal in any production system faces, there's a whole variety. So obviously the one measuring immune competence, you're really looking at environmental challenges that come from pathogens or disease-causing organisms, but there's a whole range of other things that challenges that those animals face on a day-to-day basis. So climatic extremes, people will argue that's getting more and more so the case, with, whether you're a believer in climate change or not. Husbandry practices obviously are a type of challenge for the animals. And social disruption, and what I mean by that is when we're mixing unfamiliar lots of cattle at a feedlot, for instance, can have a pretty big impact on those animals. But the important thing, I think, as a researcher is to understand that we're only looking at this little part of it, the immune response to pathogens, when there's a whole other troop of things that this animal's faced with. And all of these things, the physiological response of an animal, the behaviour of an animal, the immune response of an animal, they're all linked together. And I think it's really important that we don't consider these in isolation of these other things. So if we think about environmental challenges that our beef cattle face in a feedlot or on pasture, they respond to those with a series of host defence reactions. They might be immune defence, different behaviours or physiology, and what they manifest themselves as in their tolerance to handle stresses. And what I mean by that is that might be a stress from some sort of management procedure like weaning or marking or induction into a feedlot environment. Disease resistance, which I've talked about, and also social robustness. So what we're aiming to do, we're saying that if we can get measures of all these things, it's giving us an idea of what we're calling an animal's resilience. So what do we mean by resilience? So if you think about resilience in terms of disease, it's really about the animal's ability to maintain productivity in the face of disease challenges. That's how I define resilience. We're talking about general resilience, where we're talking about the ability of animals to maintain productivity in the face of a variety of environmental challenges, whether they be climatic conditions, pathogens, management-induced stressful situations, etc. So I really look at immune competence as just a component of resilience. So I mentioned to you that we actually test the immune competence during yard weaning. We do that for a specific reason, because we're interested in looking at the animals that can respond well when they're under stress. So as you can imagine, yard weaning is a pretty stressful period in a calf's life, and for us it gives us a really good way to mimic, if you like, for example, entering into a feedlot. So we use that yard weaning period as a time of management-induced stress, that we can test their ability to respond to a challenge when they're under stress. Because we know from experience that the animal that's the best responder out in the paddock when they're happy and with mum is not necessarily the animal that can respond best when it's in a stressful situation. So we really need to try and get a handle on that. So here in Australia, obviously internal parasites are an issue, becoming more and more of an issue, not so yet in the beef game, but certainly in the sheep game. And so we're including measures of resistance to internal parasites. Obviously that's not an issue for housed animals, dairy animals in North America. So we also look at trying to measure how the stress response of those animals to that yard weaning procedure. How have those animals handled being yard weaned? So part of that story is we look at their weight change over the weaning period, and we also include measures of an animal's temperament. So by temperament we're measuring flight speed on these animals and also doing crush scores, so to try and get a handle on the animal's temperament. And what we're really trying to come up with is this new trait that we're calling immune competence when they're under stress, because it's animals entering a feedlot, the disease incidence of BRD, etc., very concentrated to that early period when they're under extreme stress. Plus their stress response or ability to handle that management-induced stress, weight change during weaning, plus their temperament. We put all these into a mix and try and come out with some measure of resilience for these animals. So a few considerations when we thought about developing the methodology. As researchers, we need to be very conscious to go and conduct our research in an industry-relevant setting. So either on commercial properties that are representative of what's going on out there in the real world, or certainly research farms that are run under commercial conditions. It was a really important consideration that the animals we were testing also had extensive phenotypic data collected for all those important traits like growth rate, feedlot performance, etc. And that's because we were very interested in looking at associations between immune competence and these other important production traits. If we're testing across multiple locations, it's really important that we have link size across those locations so that we can start to look at some genetic parameters. And an important consideration for us is that the animals we're testing in genotypes, so that down the track this may hopefully one day lead to some sort of genomic test. So as you can see, or as you can imagine, the Angus CSIRO benchmarking program well and truly ticks all those boxes. So it's an excellent resource for researchers like me to conduct this kind of study on, because it really does tick all the boxes. So what have we been doing over the last couple of years? So to date we have assessed what we're calling resilience with all those measures we've just talked about. In a total of 1,275 calves to date during the yard weaning period. So a large proportion of those animals were calves in the benchmarking program. We've gone out to cooperative herds and tested those animals at yard weaning. So we did 520 of the H calves across 4 different farms and 436 of the J calves across 3 different farms. We've also done some testing on the Angus performance recorded herd, the APR herd that's run at Chiswick out here. And more recently we've actually done a little study with Robert Hurd at UNE looking at, because we're very interested in the association between our immune competence measures and feed efficiency. So this little study was done on 60 animals that were the absolute extremes for net feed efficiency that he'd selected for about 20 years. So they were the highs of the highs and the lows of the lows. So we're just churning through that data at the moment. So they're a really interesting group to look at. So where are we at the moment with all of this? So all our on-farm testing has been completed. The laboratory analysis to assess the immune competence and stress responsiveness is completed. So we've done all those laboratory assays, lots of those. The net feed intake or efficiency data, feedlot performance data and carcass data from the cohort 2 calves, which were the first ones we tested, is nearing completion, as you heard from Christian this morning. I'll about to say Bob. And they're continuing to collect stuff from the 3rd cohort of calves, or the J group calves. So although we haven't got any association data for you yet, because we're still just waiting we'll get that final lot of data in and start to really churn through some numbers now. I just wanted to give you a little idea of the variation that we see in some of these traits in a single herd, in a single cohort of animals that has been raised under identical conditions at the time we tested. So here's a graph where we're looking at the type 1 responses, or those skin test reactions we were looking at. So these animals have all been treated the same, and this is the change in skin fold thickness. And honestly, this is just a random 20 animals out of the first group that I grabbed, and this is what we see all the time. There's a massive variation in the responses that we see. Okay, so here, higher the response, the bigger the reaction, the better the reaction, right? But what I just really want to highlight was a huge variation we see. Similar thing with antibody responses. Now, these are antibody responses. Serum antibody in response to the vaccination we give them at the time of weaning. And as you can see, again, there's a whole variety. And this is very common. We get animals, super high responders, animals that respond hardly at all. We get that whole variety of responders. Again, same cohort of animals, all raised the same. There's an interesting one. This is the stress response to yard weaning. So how we look at this is we measure a protein in the blood called haptoglobin. And haptoglobin is a protein is a stress-related protein. It's actually an acute phase protein. And when you're under stress, the levels of haptoglobin in your blood increase. So here, if you see an animal with really high haptoglobin, means to the best of our ability, they are the animals that were most stressed and cope the least well with the situation. And as you can see again, the blue ones are, we always have a bit of a baseline level of haptoglobin in our system, but the orange or red or brown bars are 4 days after weaning, where we've profiled the haptoglobin response, and about 3 or 4 days we see a peak in that response to the yard weaning. So you can see there that obviously this animal here has been quite stressed, and the things we'll be looking at is, well, how's that affected its later performance, pasture finishing and into the feedlot. So the last one here, and again this is the same cohort of animals, just random, is the weight change during yard weaning. It's quite staggering that between, we see, now I must admit this has not been standardised to their weight at the start of weaning. This is just purely kilograms of weight change. So this will change slightly with some standardisation, but you're still not going to have an animal that's minus 13 go up to 28 kilos weight gain during the week. So, it's likely that everybody's herds have the same sort of variability in how those animals cope with weaning and the weight gain over that weaning period. Very common, we see that in all the herds we've tested. So where to now? So the really important thing for us is to now that we're getting data back from through the benchmarking program, through health data, pasture backgrounding and feedlot performance data back from Talimba and from Ranges Valley, the net feed intake or feed efficiency data back from Talimba and all the carcass data, is that we want to investigate the associations between our resilience traits and all these important production traits, because we need to understand that before we advise people that we should be putting this into place out in the industry. We need to understand all these relationships as best as we can. So this is where the huge benefit for us in working with the CSIRO benchmarking program has been. I mean, to access this kind of data, there is no way in our research environment that we could gain this industry relevant data. So, we're very thankful to have been able to test the CSIRO benchmarking calves and because it's an absolutely great resource for researchers like me to work on. So the other thing we want to do is to determine some genetic parameters. We want to estimate the heritability of some of these traits in beef cattle in our production environments, and also estimate the genetic components of some of these associations that we're interested in. So here's the slide that we're talking about production costs. So it's a common belief, and it has been for a long time, that if we select for resistance to disease, that there's going to be a trade-off for production. Now, we're trying to answer that question more clearly. So, as you can imagine, if you're mounting an immune response, it takes energy, it takes nutrients away from production. But the counterbalancing, and that's why I put this on a seesaw, the counterbalancing cost of counterbalancing this cost of resistance is the metabolic cost of disease. And what we find in our low responder animals, well, what we expect is happening in the low responder animals is that their immune systems are chronically activated because they can't clear infections. So there's this subclinical disease that just ticks away, they never quite get rid of it. So, this is really important for us to understand the link between our immune responsiveness and production. And back to your question there earlier, what we found is, for instance, in the dairy industry, we've selected heavily for production. For a while, it dragged. The most healthy animals were the higher producing animals, and it trickled along okay for a while till we pushed them too hard, and we got to a point where those animals started to break down. And that's where they've landed in the trouble they are now. So I actually think that we'll find positive correlations for some animals, not all animals, but that if we work on both production traits and immune competence or health traits together, we can increase both simultaneously, even if there is a slight negative correlation between those two. We can still work on both of those. All right. So just as a summary, as I said, we're not advocating to stop selecting animals for resistance to specific diseases, especially if they're very economically important diseases for your industry. But we ask that people consider looking at general immune competence with that selection strategy. So if we combine those with desirable stress responsive traits, animals with good temperament, and one thing we've been thinking about and we're looking into now is incorporating into this resilience index some measures of heat tolerance, and that's especially applicable to animals in feedlot environments where we have issues with heat waves and looking at animals' ability. So we're doing some work on that now and looking at associations between that and our immune response traits. And the overall goal of all this work is to breed resilient and adaptable, productive livestock that suit our production systems. So thank you. I just want to make a few acknowledgements here. First to the CSIRO technical staff who do a mountain of work, and Bob will know very well how big a job these guys do. We have been at farm sampling with Bob at 1 in the morning, haven't we, Bob? So look, a huge thanks to the CSIRO staff. They put a mountain of work into this. A really big thanks to Angus Australia, particularly Peter Parnell and Bob Dent and more recently Christian, for the opportunity to test these benchmarking calves. I mean, it really is the thing that's made this research worthwhile. And as I said before, if we didn't have access to these animals, there is no way we could look at these associations between all these important traits that we're interested in. Very big thanks to the cooperator herds who agreed for us to come out and test on farms. So Hugh's here today. We did some testing at Glenroy, and Rob's here from Ardross. And so very big thanks to you guys and your managers and staff for letting us come on. It's a fair inconvenience for them to have to get cattle in for us, and they're always super cooperative and very helpful. So we really appreciate you letting us do that. Of course, very big thanks to MLA who funded all this work. Thank you.